Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate Since we've been practicing our factoring skills with quadratics, the next logical step is to say, well, how do we apply this stuff to polynomials, right? Quadratics are just a small little subset of polynomials. So I have 3 examples for you. So the first thing I want you to recognize is that the degree is 3. Don't let that scare you. When you're trying to factor polynomials using GCFs, the first thing you want to do is figure out what is the greatest common factor out of all of the terms. All right, so the first thing I want to do is make sure that I understand what I'm reading. So I can say I have a 3x cubed, I have a positive 12x squared, and I have a negative 36x. So let's look at the numbers first. What is something they all have in common? 3, 12, and 36, they all have a 3 in common. Next, let's look at the variables. I have 3x's here, I have 2x's here, I have 1x there. So the most they have in common is 1x. So I'm going to factor out a 3x. So I'm going to write 3x up front because that's my factor term. Now when you factor things out, we're dividing. So if I take the 3 out, 3 divided by 3 is 1. And then if I have 3x's but I take 1 out, I'm left with 2. Now let's look at the next term. When you factor stuff out, you're dividing. So what's 12 divided by 3? 4. And if I have 2x's and I take 1 away, I'm 1 left. Lastly, I have a negative 36 here, but I'm factoring 3 out. 36 divided by 3 is 12. And it has only 1x. So when I take this one out, x out, it's gone. Now you can always check your work to see if you factored enough out. 3x times x squared is 3x cubed. 3x times 4x is 12x squared. 3x times negative 12 is negative 36x. Now let's look at what remains. Can we factor that? Answer, yes. So now let's put all this together and look at what this really looks like completely factored. We have our 3x from the beginning. Now we have an x plus 6, and now we have an x minus 2. And there you have it. So we're going to follow a similar process in this example. So the first thing we want to figure out is what's the GCF? In other words, what's the common factor? And we want it to be the greatest common factor. Well, let's look at the numbers. Notice 10, 50, and 60 are all multiples of 10. Sweet, that makes it easy. So we know 10 can be factored out. Now let's look at the variables. We have an x squared, we have an x, but wait, this doesn't have any x's in it. So what that means is I cannot take any variables out. The only thing I can factor out is a number. See, in the previous example, they all had x's, right? So I can take something in a certain amount that they all have in common, which is only 1. So after we figure out our GCF, let's actually factor it out and rewrite it. So 10 comes out. Now what's left? Remember, we're dividing. So 10 divided by 10 is 1. And I'm not taking any variables out, so it stays. 50 divided by 10 is negative 5. And 60 divided by 10 is negative 6. Does this remaining quadratic factor? Yes, it does. Now, let's rewrite our final answer. Don't forget your GCF. Let's look at one more answer here. In this problem here, notice it's a binomial. So again, the first step is to figure out what's the GCF. Notice numbers are in common, 2 and 6. The common factor is 2, and they both have a variable. So this has 2 x's, but this has only 1, so they only share 1. So we're going to factor that out. Now let's rewrite it. So the GCF is 2x. So now let's divide. 2 divided by 2 is 1. If I have 2 x's and I take 1 out, I have 1 left. 6 divided by 2 is 3. And it has 1x, but I factored it out, see? So it's no longer there. Now, can this be factored anymore? No, it's already completely factored. There's my answer.